Welcome back, ladies and gentlemen. Miss Burkers here. We'll go through lesson 4 now of atomic structure. Hopefully now you've started to get the hang of the routine here. So there are 8 questions here for the knowledge check. Pause the video, answer them either in your booklet if you have a paper copy or just on any other paper if you don't. And we'll go through the answers in a minute. So hopefully you have all the answers written down that you need, and we'll start here with question 1. The number of elements in period 1, we have 2 elements in period 1. We have hydrogen and helium. The columns of the periodic table, we call those groups. The symbol for lithium is Li. Again, remember the first letter needs to be a capital, the second one needs to be lowercase. The symbol for argon is a R, again, capital lowercase. The 3 ages of human history, hopefully you remember that these are the Stone, the Bronze Age, and the Iron Age. A rock with a metal chemically bound to it, we call that an ore. The Earth is approximately 4.5 billion years old. So if you have anything in that range, that's fine. How many elements are there in group VII? 5, 6, 7. All right. In group 7, depending on exactly which periodic table you're looking at, but it should be 6. Some periodic tables might have the bottom group out, so you might, or the bottom period out, sorry, so you might only have 5, but so if you have that based on your periodic table, but most should say 6. So today we're looking at the periodic table and how it was put together. So back in the 1800s, we knew 50 different elements. So we now know that there are approximately 118 different elements that we know of now. So we didn't know all of them that we know now, but we did know quite a few. We also knew their chemical and physical properties. So if you remember, a property of something is what makes it different from the other elements. And so the chemical properties are how it reacts. And physical properties are things that you can observe with your 5 senses. What it looks like, how it feels, things like that. So we knew 50 different elements, and we knew quite a few of their chemical and physical properties. Another thing that we did know is that they all had different masses. So we could place them in mass order from largest to smallest, or we could put them from lightest to heaviest. You might notice that the periodic table to this day is still placed in that order, because we know the smallest, lightest element is hydrogen. And as we move across the periodic table and then down the groups, they get bigger and heavier. In about 1864, a man named John Newlands came along. And he saw that every 8 elements, there was a pattern to their chemical properties. So when he placed them in this order of atomic mass, so from the lightest to the heaviest element, element number 1, so the first element that he placed, had certain properties that were not the same for elements 2 through 7, but then element number 8 had again those similar properties. And then he looked, element 2 had similar properties again to element 9, but they were different from element 8 or element 1. So he noticed those patterns. So he thought a group of 8 a group of 8 notes in music, we call that an octave. So he used that musical language octaves to talk about this pattern of 8. So John Newlands noticed the pattern of the chemical properties every 8 elements, and then he talked about those 8 elements as an octave. However, it only worked for the first 3 periods. After that, it started breaking down. The pattern didn't fit as well after that. After this pattern, the pattern broke down. A couple years later, in 1869, came a man called Dmitri Mendeleev. Now, this is a name that we've talked about before in the booklet, so hopefully it's starting to ring a bell. You can see by the spelling of his name that he wasn't English. He was actually a Russian chemist. And he worked at the St. Petersburg Technical Institute, and he did a lot of chemistry research. So through all of this research he did, and based on the things that John Newlands and other scientists had discovered about all of these elements, he took these elements and he did something different with them. He did place them in order of atomic mass. However, he had to change that order a little bit because new science had come out from before John Newlands because of different research different scientists had done. He grouped elements with similar properties together. Doing this, he had to leave some gaps. He left the gaps. And this leaving of the gaps is the thing you need to know about Dmitri Mendeleev. So, we know John Newlands did the octaves. Dmitri Mendeleev left gaps. These are the big important things that these scientists did. So these gaps meant that this pattern that John Newlands had noticed didn't break down. So the pattern continued. So he was able to say that, for example, if he had element 6 and 7, he was like, these patterns don't fit as well. I need to put an element in between. And he wasn't able to say, okay, I have element 6.5. I'm just kind of naming it here. But he was able to tell the various properties that this element that fit between 6 and 7 might have. So, looking at the modern periodic table, we haven't talked too much about it yet, but you will see that you will learn more in the future, that all the elements in group 1, for example, have very similar properties. Group 1, they react very violently with water, and they are very reactive elements. You might know group 0 as the noble gases. That's because they're very unreactive. Whereas group 7 are reasonably reactive compared to a lot of the other elements. So based on that, we can tell certain things about certain elements based on the group they are. We now know that these patterns that exist in the groups depend on the inner parts of the atom, which are called protons, neutrons, and electrons. And you might remember some of this from previous years, from previous lessons. But when Mendeleev put them in that order and left those gaps, he didn't know about protons, neutrons, and electrons. They hadn't been discovered yet, which means that these predictions were even more impressive. If you want to know a little bit more about this in a slightly more entertaining video, TED-Ed, if you Google TED-Ed and Mendeleev, has a really good video describing Mendeleev and exactly what he discovered and how he discovered it. So if you want to watch another video to understand more about it, that's a good video to watch. All right, so now I'd like you to pause the video, this video, go check out this video here if you'd like to, and then give these questions here a try, these 6 questions. We'll come back in a minute to take up the answers. All right, so hopefully you've had a chance to go through these questions and you've written down the answers somewhere. So now I'd like you to go through and correct your answers, check that they're right, and if they're not right, write down the correct answers so you have them. So how many elements were discovered by the 1800s? So we had about 50 elements had been discovered. The Greek word that means 8, we're looking for the word octave. Where was Dmitri Mendeleev born? This was in Russia. Mendeleev placed the elements in order of their atomic mass. Mendeleev, what did he do with unknown elements? He left a gap. And that's the big important thing. If you remember nothing else about Mendeleev, you need to remember that he left gaps. And what did he notice about the properties? He noticed they had a pattern. Pattern in the groups. So within, for example, group 1, the elements all had the similar properties. So that was back the end of the 1800s. A lot of time has passed since then. So some of these unknown elements that Dmitri Mendeleev says there needs to be an element there, we've now found an element that fits exactly into that gap he left. So we know, for example, gallium, he was able to predict gallium, predict the properties of gallium, but it hadn't been discovered. It was discovered about 50 to 100 years after Mendeleev died, but it fit exactly into a space he left on the periodic table. So, in a couple of years after Mendeleev, in 1904, William Ramsay was able to discover the elements in group 0. They are called the noble gases, but they were not part of Mendeleev's original design. So I've mentioned before that the noble gases are very unreactive. So because they are very unreactive, they are harder to detect. And because they're so hard to find, they hadn't been discovered yet. So the modern periodic table, so the one we look at today, is arranged in order of atomic number. This wasn't something that Mendeleev was able to use because this is the number of protons in the element or in the atom. So Mendeleev didn't know protons existed. So now we know of protons. For example, element number 1, hydrogen, has 1 proton. Element number 20, calcium, has 20 protons. So we put them in that order. All right, and then we still use those columns that we call groups, and the periods as well fit into that atomic structure. And we use we call it a periodic table because the properties occur at a regular interval or they occur periodically. So again, here's another video you can watch. You can click on the link that your teacher has sent to you, and then you can go through, watch it, and take some of the things out of there. This checkpoint and try. There are 2 questions, each worth 2 marks. So I'd like at least 2 bullet points or 2 sentences for each of them, describing 2 different points about it. So based on what we've talked about in this lesson, I would like you to go back, try to answer these questions, scroll back through the video if you need to, pause the video, write these answers down either in your booklet or on a scrap piece of paper, and we'll come to the answers in a minute. So hopefully you have some of these answers here for these questions. So the early periodic table, some elements were placed in groups with elements that had very different properties, described 2 changes that Mendeleev made to overcome this problem. So he left gaps for elements that had different properties. He also changed the order of some of the elements based on their atomic mass, because new science had come out that said that the order of the atomic mass was different. Again, they're still discovering things all the time at this point. Still today, they're discovering things they didn't know before. And then the second part of it explained how the discovery of protons enabled scientists to improve the order of elements on the periodic table. We haven't learned too much about protons yet, but we do know that they could be arranged be arranged in order based on the number of protons instead of just on the mass, which is a more accurate way of doing it. And the number of protons also helps us understand the chemical properties being the way that they are, which allows us to then put them properly into their proper groups. So hopefully you have those answers there. I would like you to give a go to this knowledge and application check. There's 10 questions, so I'd like you to grab your booklet or your piece of paper, pause the video, answer the questions, and we'll come in with the answers in a minute. All right, so hopefully now you've had a chance to go through this knowledge and application check, giving these questions a try, and we're going to go through the answers now. So question 1, how scientists knew elements were all different. So we knew they were different because they had different properties. How the elements are arranged in the modern periodic table. The key word here is this modern. So today we use the atomic number or the proton. Number. Define octave. An octave is a group of 8, usually used musically, but can also be used in science occasionally. The scientist who used octaves in his table, that was John Newlands. What Mendeleev did with the unknown elements, he left a gap. What did Mendeleev notice about the properties of elements in the same group? They had similar properties. When did Mendeleev create his periodic table? That was in 1869. The group that hadn't originally been considered, that was group 0, or the noble gases. Remember that in the early 1900s, William Ramsay discovered those. All right, the discovery of the new elements today prove that Dmitry Mendeleev was correct to leave gaps in his periodic tables. It's because those new elements fit perfectly into the gaps. Why we have discovered more elements today compared to our ancestors 50,000 years ago. A big reason for this is technology has improved. Because we have better technology, we're able to discover more things. The other side of it is that these discoveries build on each other. So for example, Dmitry Mendeleev would not have been able to design the periodic table he did if he had not known all of the properties that had been discovered by other scientists. So if that time hadn't been taken to discover all of those properties, Mendeleev would not have been able to leave gaps and come up with properties for the elements that would fit in those gaps. And that's a big part of science, is that so many things that we discover today are based on experiments and things that we've done in the past, which is why we have these history lessons within science, so you can understand how we got to the point we got to today. So that's the lesson for today. Hopefully it makes some sense. If you have any questions about it, don't be afraid to email your teachers to ask those questions, and I'll see you next time for the next lesson.